took off there with the major arc and the minor arc. You all know the minor arc is just a small one. Okay, you know the way they said, so there's a bit of a circle there, 6.4. Okay, that's the minor arc, and the major arc is all the rest of the way around. Okay, so that's where the 25.0159 came from. Is that okay? Right, so then the minor arc is to the major arc, so it's 6.4 is to 25.0159, and they want it in the form 1 is to something. So
it's not on the thing.
oh, sorry, I turned it off. Okay, so minor arc, major arc, right? So minor arc is to major arc, and then it says 1 is to something, so divide each side by 6.4, and you'll get 1 is to, does anyone have an answer for that? To 3 significant figures. 3.908?
Yeah.
Okay, so 3 significant figures means I'm only allowed to write 3 numbers. 3.90, if I cut it off there, it'll be 3.91. Is that okay? Are we good? Right, okay, I'll go back and do question 1 now. Yeah, sorry, I will.
Excuse me, would Susanna Grisleka from Patrick 1 come to reception now, please?
Yes. Yeah. Whoever, I don't know who now I know who I'm looking at. Thanks. Okay.
Excuse me, would Kate Darcy, first year, also come to reception, please?
Okay. Okay, and they want the ratio of the area of P to Q, isn't it? So I want the area of P is to Q. Area of Q. Is that right? Okay, so I tried to draw it out as accurately as I could. Right, okay, so instead of putting in P, I'm putting in P. I'll call that P. Right, I'm going to connect that corner to the midpoint there. So I'm going to connect, I'm going to call that area A, area B, and I'm going to call this area C. Is that okay? Just to start with. Okay? So if I did area of P plus C, P plus C together, area P plus the area of C, it's a triangle, isn't it? Okay, so it would be half the base, and I'm going to call the length here, it's half, multiplied the base is the length, and the perpendicular height is this line here, and they told me that's the midpoint, so it's L over 2. Okay, is that alright? So the P plus C together, when I multiply all that out, I'll get L squared over 4. That's the area of P plus C. L squared over 4. Okay, are we good with that? Right, now I'm going to do A plus C. So the area of A plus C. So see the way A plus C, wait now, I get a different color pen for a minute. So A plus C is here. Okay, so I'm going to use this as the base, yes, and the perpendicular height, so I'm turning it sideways. So this is the base, so the perpendicular height would be L as well, wouldn't it? Perpendicular height is the distance from the bottom line to the top, which would, it's on the outside, and it's L. Would you agree? Right, okay, so A plus C, it's a half, the base I'm using as L over 2. So it's a half, the base I'm using as L over 2, and the perpendicular height is L, which is L squared over 4 again. Is that okay? So what that means is that when I got the area of P and C together, it worked out to be the same as A and C together. Agreed? Right, so there's a C at each side, so that means the area P is equal to the area of A. Okay? Is that alright? Okay, so now I'm going to split up each section and mark it how many C's it is. Right, okay? So you know the way the area of C here, right, is, I'm going to just put in, this is a perpendicular height, I don't know what it is, right, okay? So the area of C would be L over 2 by H, agreed? So the area of C is L over 2 by H, agreed? Right? Because it's a square, girls, this is also H. Right, anytime I use one of these mediator lines where it made a triangle with the diagonal, it's also a H because it's a square. Okay, so the area of P, so I'm going to go area of C, what I wrote down there a minute, is, what did I say, it was a half the base by the perpendicular height, so it's a half times L over 2 times H. Would you agree? Right, okay, so that would be LH over 4. That's the area of C. Area P. Right, area P is a half times L multiplied by H, and that H is the same because it's a square and they're the same height. Is that okay? As you can see, there are 4 squares, it's 4 squares. That's only because it's a square. If it wasn't a square, you couldn't assume they were the same height, but because they're a square, you can assume they're the same height, right? Okay, so the area P is LH over 2, which would be twice C, wouldn't it? 2 C's. Would you agree? It's double that. If I double that, I'll get P. Right? Okay? So that means area of A, because I've already proved that the area P and the area of A are the same, that means area of A is also 2 C's. Isn't that right? Okay. Right. I'm going to, for B, right, okay, for B, actually, you know, I'm not even going to do that. I'm going to say, you know, would you agree that B is P and C together? It's the same as P and C, because it's a mirror image, isn't it? So B would be the same as, this triangle up here would be the same as this triangle down here, wouldn't it? So it would be P and C together, agreed? Okay, so I've already established that P is 2 times C, and another C, so 2 times C plus C would be 3 times C. Is that okay? Are you with me? Okay, so I'm going back to my diagram. I've just established that B is the same as 3 times C. Right? I've established that A is the same as 2 times C. Right? And I know that P is 2 times C also. Agreed? Okay, so Q, I'll get a different color pen again. So back to the original. Q is here. So I want to do the area of P is to the area of Q. So how many C's is P? It's 2 C's, isn't it? Q is how many C's? 5 C's. So the ratio is 2 to 5. Okay, that's a very hard question. I don't know why that was question number 1, because it's really hard. Okay, right? Are we good? 2 is to 5 is the answer. So I've basically broken up everything and written it in terms of C's. And because it's a square, we have lots of stuff that's the same. Okay, so where I got that 3C is I got the area of this bit down here. It's the same as this bit up there. Where I got this 2C in there is I proved the area of this bit in the middle was the same as the area of this bit down here. Okay? Okay? Are we okay?
What does it say over 5 beside 2C?
Here,
Yeah.
it's 2C is to 5C. So there's the answer. Sorry, squashed in there after all that. Okay, but I needed the diagram to show that. Are we good? Okay, that was number 1. So you told me number 2 was okay, and I did number 3. Number 4?
Yeah.
Right, number 4. Right. Determine the capacity of the following swimming pool with the dimensions given. If the water can supply, the capacity is another word for volume, you know that, don't you? At 10 litre per minute, how long would you take to fill the pool? Right, okay, so what I need to do is I need to get the area of the front and multiply it by the distance back. It's a prism. Yeah. Yeah. So area of the front multiplied by the distance back, and the front is a trapezoid, isn't it? Because that's a parallel line and that's a parallel line. Agreed? Okay. So this is A, this is B, and this is the perpendicular distance. So A is 1.5, B is 3 meters, and this is 25 meters, which is the perpendicular height. So remember, trapezoid, A plus B over 2 multiplied by the height, which is 1.5 plus 3 all over 2 multiplied by the height is 25. Okay, and then because it's a prism, I have to multiply it by the distance back, and the distance back is 8, so I must multiply that by 8 as well. 0.5, oh yeah, I have the notion of doing that. Will someone do that for me, please? Uh, 4.5 by that is 112.5 by 8 is, it works out 450. Are we okay with that? Okay. And then if the water can supply at a rate of 10 litres per minute, how long would it take to fill the pool? Okay, so we need to do conversions here, right? What I'm going to do is I'm going to change everything to centimetres, because the only conversion that I remember is 1 litre is equal to 1,000 cm cubed. That's the only conversion I ever remember when it comes to capacity. And the reason I remember this is because the graduated cylinders in the lab, some of them have mils on it, right, and some of them have cm cubed on it. So a mil and a cm cubed is the same thing, okay? So that's how I remember that. So this is the only conversion I remember. Okay, so I'm going to go back and do all that, but I'm going to do it in centimetres, okay? So A would be 150 centimetres, B would be 300 centimetres, divided by 2, multiplied by H is 2,500 centimetres, and then multiplied by the distance back, which is 800. Okay, and then put that into the calculator, and I would end up with, so when you just multiply the numbers with that, and then I have to do 4, I say I have to put on 6 noughts onto it. Someone might do that for me. Is that right? Is it 450 and 6 noughts, or is 45 and 6 noughts?
No,
450 and 6 noughts, right? Okay, 1, 2, 3, 4, 5, 6. Okay, I know that 1,000 centimeters is 1 litre, so if I divide by 1,000, okay, that will be 450,000, right? Per minute, so that's minutes, because every minute 1,000 centimeters cubed goes in. Sorry, no, it's 10 litres per minute, isn't it? So I have to multiply that by 10. Okay, so I'm short, I have an extra naught there, so when I divide there, I will get 45,000 minutes, right? And then I'll divide that by 60. Does it give the answer in minutes at the back, or does it turn it into hours? Yeah, so divide by 60 to turn it into hours, and you get what you get. Is that right? Okay, are we good? Okay, yes. Yeah, you can. And number 5, as I say, I hope you spotted that it was in radians, and we haven't done that yet, so you left it out, yes? Right, okay, and then number 6, am I doing number 6? Right, okay, so number 6, how am I going time-wise? I have plenty of time. Okay, so here I have a cone, and the circle on top is R. This is L, this is theta. And it says, a net of a cone is shown in the diagram. Use this diagram to show that the curved surface area of the cone can be written as the area is equal to that, where R is the radius of the circular base and L is the slant height. Right, okay, so all I know is area, if I was to get the area, that shape there, it would be theta over 360 multiplied by pi R squared. Agreed? Okay, but in this case R is actually L. The radius of that circle is L, so it'd be pi L squared. Agreed? Right, okay. I also know that if I was to get the length of this line, right, okay, which they called S, so if I was to get the length of that line, it would be theta over 360 multiplied by 2 pi R, which is L in this case. Agreed? Okay, but this line here, see this bit here, S, if you were to straighten out that circle, right, if you were to turn that circle into a straight line, they'd be the same size, wouldn't they? Because the distance around the top is equal to, when you curve that over, when you curve that over, that would be the circumference of the circle, wouldn't it? So I know that S is also equal to 2 pi R. be the circumference of that circle. Agreed? So I have S here and I have S here, so I can let them equal to each other. So that means 2 pi r is equal to theta over 360 times 2 pi L. Agreed? There's a 2 and a pi at each side, so knock them off. So that means r is equal to theta over 360 times L. Right, I'm eventually coming back to that, so I'm going to replace that theta over 360. So I'm just going to rearrange this. So theta over 360 equals r over L. Okay, just brought that L underneath the line. Okay, then back to the area, which is what they wanted me to get. The area is theta over 360 multiplied by pi L squared. But I've just said that theta over 360 is r over L. So that means A is equal to r over L times pi L squared. So one of those L's will cancel and you'll get area is equal to pi r L, which is what they wanted me to prove. Okay? Right. Okay. Right. What I have now is some exam questions. Okay, we're not going to have time to go through them all. You're getting your test first class on Thursday. So if you collect one of these, wait, now if I see for tonight, will we have a go at page the first sheet, say front and back, so page 1 and 2. Does that bring me to the end of a question? It does. Yeah. So the first page, the front to the back, okay? And we do the other ones tomorrow. Is that all right? So will you, if I leave those there, right? Okay. And you may notice, girls, some of the I gave them out to third years by accident. I scared the living bejesus out of them when they read the questions, right? Okay, but some of them put their names on the sheet and then cross out the names. Okay, but it's definitely 3 days ago, so any germs that were on them are now dead. Okay, is that right? So I gave them out to third years by accident and I scared the life out of them. Okay, so will you grab a sheet on the way out, and is it time to go out? No. Clean your desk. If you want to come and grab a sheet and go back and clean your desk, do. Right. So the front and the back of the first page for homework. Yeah, I'd say you can just head off. It's only a minute.